So now let's start our next section. This is 14.5, and we're talking about surface area. So let's start with the definition of surface area. If f and its first partial derivatives, so that's fx and fy, are continuous on the closed region R in the xy plane, then the area of the surface S given by z equals f of xy over the region R is defined as, so the surface area, it's equal to double integral over your region R, the square root of 1 plus your partial derivative with respect to x squared plus the partial derivative with respect to y squared dA. So this is the formula you want to keep in mind for surface area. Now let's look at a few examples involving surface area. So let's look at our first example. Find the surface area of the portion of the plane z equals 2 minus x minus y that lies above the circle x squared plus y squared is less than or equal to 1 in the first quadrant. So here, just so you know, we have this plane. That's the equation of, that's the graph of this equation right here. It's a plane. It's going down here, and then you have the circle of radius 1 here. And you want the surface area of the region that lies above this circle in the first quadrant. So here our function f that we're trying to find the surface area for, this is 2 minus x minus y, and this is the function we need to find the partial derivatives of. So the partial derivative with respect to x is -1. The partial derivative with respect to y is also -1. So then our surface area, I'll just call it S, it's the integral over this region R, the square root of 1 plus our fx squared plus fy squared dA. Well, now this is the square root of 1 plus -1 squared plus -1 squared. So that's really just square root of 3. Now here, our region is a circle, and it's just the circle that's in the first quadrant, circle of radius 1. This is our region R here. And because we're working with a circle, We should probably work with polar coordinates. So let's use polar coordinates now. Well, this will be from 0. Theta goes between 0 and pi over 2. R goes from 0 to 1. It's square root of 3. And then anytime you change into polar, you get an r dr d theta. So this is the square root of 3, r squared over 2 from 0 to 1. So this just corresponds to square root of 3 over 2 d theta, or square root of 3 over 2 theta from 0 to pi over 2. So square root of 3 pi over 4. And that is my surface area of my plane that lies over this region, this part of the circle of radius 1 in the first quadrant.